Okay, welcome to our first example problem. We're going to be looking to simplify the radical, the square root of 48. I'm going to show a long methodology of doing this, basically to show that this is how we come up with these answers when they're a little more difficult to factor out and to figure out what the simplified radical is going to be. But this should be a pretty easy one that we should have no problem doing. So first thing we're going to do is we're going to factor 48 into a product of primes. So the square root of 2 is times the square root of 24, which is the square root of 2 times the square root of 12, which is the square root of 2 times the square root of 6, which is the square root of 2 times the square root of 3. Since we are solving for squares, we're looking for pairs. And so in this case, we take the square root of 2 times the square root of 2, and the square root of 2 and the square root of 2. And those are going to match up so that we end up with 2 times 2 times the square root of 3, which is in the simplified form 4 times the square root of 3. Now, as advanced honors geometry students, we should not have any problem coming up with the perfect squares that are factors of 48. So, in doing that, we can typically look at the number 48 and find the perfect squares that are factors. So in this case, that would be the square root of 16 times the square root of 3. Now we can simplify the square root of 16 as 4 times the square root of 3. This cuts down on a lot of work if we are familiar with what our perfect squares are. The next problem we're going to be looking at is a simplification of radicals and that we're going to be adding together. So we're going to take the square root of 18 plus the square root of 32 plus the square root of 75. In doing so, the first thing we want to do is go back to our initial methodology. What's the largest perfect square that goes into 18? And that would be the square root of 9 times the square root of 2. Again, square root of 16 times the square root of 2. And the last one would be the square root of 25 times the square root of 3. Now we'll go ahead and simplify our perfect squares. So this one becomes 3 times the square root of 2 plus 4 times the square root of 2 plus 5 times the square root of 3. The thing we need to keep in mind is that radicals are treated like variables, and the numbers that are in front that are being multiplied, such as coefficients, with those variables. So we would treat such as this situation, such as square root of 2 as x and the square root of 3 is y. So we're not going to combine unlike terms. So in this case, though, we have the square root of 3 is 3 times the square root of 2, 4 times the square root of 2. This is 7 times the square root of 2 plus 5 times the square root of 3. Our like terms are combined. Our answer is complete, and we are simplified. Our next example is a simplification of a radical that is a fraction under the radical sign. So we can never have a radical in the denominator. That is against the rules of math. So we don't do that. We've got to get that out of there. So we're going to show the long way, and then we'll show a little bit of a shortcut. So the first thing I'm going to do is I'm going to rewrite this as the square root of 5 over the square root of 3. Since I cannot have a radical in the denominator, I'm going to multiply this value with a value of 1 in the form of the square root of 3 over the square root of 3, therefore maintaining the same value, but eliminating the radical in the denominator. Square root of 3 times the square root of 3 is 3. Square root of 5 times the square root of 3 is the square root of 15. This is simplified. We can also write this as a fractional coefficient of the square root of 15. Now, a shortcut method that you can look at if you want to save time is basically to square your denominator and then multiply it by your numerator. And that would be a shortcut method that you can use. Please be careful when using this because you don't want to make mistakes That'll come back to haunt you. All right, so now our next example, we're solving a quadratic. And there's two methods we can use. The first method is our good old SOS method of simplify, operate, simplify. So we're going to do that. We're going to subtract 9 from each side of the equation. And we end up with x squared is equal to 16. Now we're going to take the square of each side of the equation. And we would end up with x is equal to both positive and negative 4. The second methodology we could use is our factoring method, where we get all of everything to the left side of our equation. That's the side we're usually most comfortable with our variable on, and 0 on the right. So we're going to subtract 25 from each side of this equation and end up with x squared minus 16 equals 0. This is a difference of two squares binomial, very easy to factor. Basically, you're going to end up with x plus 4 and x minus 4. Now we set each of those factors equal to 0. And we end up with x is equal to both positive and negative 4 again. Both methodologies work well, especially if you're unfamiliar with your perfect squares and you need to do some factoring work. Okay, depending on what happens with either situation, you should not have any problem learning this method. Okay, our next problem is another quadratic. So what we're going to do now is we're going to get both or all of our terms on the left side of the equal sign so that our quadratic is equal to 0, and then we can factor it. So we're going to add 16 to each side, end up with x squared minus 10x plus 16 is equal to 0. Now we're going to use our reverse FOIL method that we acquired when we were in algebra, and we're going to come up with x minus 2 and x minus 8. Okay, just as a quick refresher, the factors of positive 16 that add up to negative 10. So we're going to now set each factor equal to 0. And in both cases, we simplify and we find out that x would be equal to 2 and 8. Both values are checkable. We can plug those in. 2 squared is 4, minus 10 times 2 is 20. 4 minus 20 is negative 16, that works out. 8 squared is 64, minus 10 times 8 is negative 80. So 64 minus 80 is negative 16, that works out. We always should check our work to make sure we're getting the correct answer. The last problem in our group of examples for section 9.1 is x squared plus 5x equals 0. And this is a problem that's a pretty basic problem. Since we've already got everything to the left side of the equation, now what we're going to do is look for a common factor between each of the terms on the left side. In this case, we can factor an x out, so we would do is have x times the quantity x plus 5 is equal to 0. Now we set both factors equal to 0. X equals 0, x plus 5 equals 0. Therefore, x is equal to 0 and negative 5. Easy problems to do. Good luck.